morning, everybody. Whoever's here. Let's see. Oh, we got 8, 9 people, according to Twitch. Good morning. Welcome to Monday. Another wonderful Monday. We are in the belly of the beast now. It's week 7. Middle of the semester. Good morning, Matt. I got dynamics. Does that mean you have a test in dynamics, or you're just in dynamics? Tests, yes. So looking at your guys' classes, I'm just curious. Morning, Joey. Do you guys typically have 1 midterm, 2 midterms, 3 midterms? Like, what does the exam structure in your other classes look like? And does the fact that our exam happened at the end of week 9, does that help spread things out? Not that we're going to move our exam necessarily because it fits within the class, but I'm just curious about what you guys have around this time. I mean, it's the middle of the semester. We are waist deep, shoulder deep, whatever, in all of the mud and trying to keep moving forward. So what does that mud look like for you guys? What are your exam structures like? Matt, you have dynamics. I know you guys had physics. Okay, so Matt says solids, diffie-Q, dynamics, and EE concepts all have 2 midterms. So, okay, that makes sense. That's a lot of sophomore level courses. Sophomore level courses. JR, good morning. What about you guys as freshmen? I know most of the students typically tend to be freshmen. A lot of you guys are mechanical and aerospace engineering. Aurora, this is your only course with 1 midterm. So does it help that it's in week 9, or does week 9 also correspond to other midterms? I'm just trying to think of like the structures that you guys have. Like, I don't know. Joey says there's 2 midterms for chemistry 108. Okay. Right, chemical engineering. And physics 107. Okay, so but Joey, so you've got 3 weeks in a row. Does that help that they're spaced out? Or would you rather have them all in the same week? Aurora, you said that helps. Because we used to have the midterm at the end of week. Okay, good. We used to have the midterm at the end of week 7, so right before spring break. Obviously, we don't have spring break this year. That's okay. We will all mourn the loss together. But it seemed like everybody had it didn't quite fit well with the course. Like, I felt it was kind of an awkward place to have it. And then everybody has their midterms before spring break. So I was just curious, since we moved it to the end of our MATLAB material, if that's helpful. Okay, so, oh gosh, I went to my undergrad. We had quarters, so we had 10-week semesters, and then we had a week of finals. So we only had 10 weeks to study for, which was amazing. My first year of grad school, I went to a semester system school, and I remember studying for those first set of finals after like a full 16-week semester, and it was brutal. It was like there's so much material that's covered in the course of a semester. It's just ridiculous. Thank you, Joey. Yep. So our midterm. Okay, so before we begin, just to give you guys some context and some strategies moving forward, our midterm is at the end of next week. So we've got about a little less than 2 full weeks, but we got 2 weeks. So it's Saturday, March 27th at noon to 2. It starts at noon. It'll end probably at about 1:30, but no later than 2. So I've had a couple questions about what the midterm's going to look like, what to study for, and The midterm will be administered via UB Learns. You will be proctored via Zoom. So you'll get your Zoom link. There'll be a TA or an instructor that's going to monitor your specific Zoom link. It'll be based on last name. And it'll be administered via UB Learns. So you'll be given a series of questions all at once that you will have to write short programs for. So you'll pull up MATLAB, have access to MATLAB, make sure you guys are familiar and in charge of everything you use for MATLAB. So you can't be just slugging along. So you should be well practiced in opening MATLAB in some way, shape, or form, whether or not it's the desktop application or the online version. But you'll write a short little program for each question you have. I don't know how many questions it's going to be yet. I don't know how long you will have to do it yet. We are still putting it together, which I wish it was done, but it's not done. But I will have more information for you guys Friday. But you'll be writing short programs, and then you'll be submitting your files. That's what the midterm is going to look like. You will have access to anything except for other people. So you can use MATLAB Help. You can use your textbook. You can use the internet. Just can't talk to other people. Studying strategies. So my suggestions for studying is to keep doing the homework. Do the homework. Do this week. So this week is probably the hardest set of material for students. I don't necessarily think it's hard in terms of like understanding conceptually. It's just hard in terms of actually implementing it. So I suggest you continue focusing on getting this week's material done, really focusing on loops, because loops will incorporate branching statements. It will also incorporate input-output. It will incorporate most of the stuff we've done before. This material builds on itself. So focus on moving forward with the homework. Do really well to try and understand loops because they're very key, they're very important, they're very useful structures in programming. So that's my strategy, my suggestion for moving forward. If you want to do some sort of review, go back, read through the notes, and hopefully all of it makes sense now. The notes are a little bit more theoretical. I made them more theoretical because I wanted to make sure our lectures were focused on examples. So just go back through, just glance through the notes, read through the notes, make sure you understand most of that concepts, most of that stuff. But my best suggestion right now is practice with the homework. Go back, maybe redo some of the challenge activities. I don't know if your solutions save in the challenge activities, so maybe go back and do some more challenge activities. Revisit them, see if you can do them faster, or if you remember, have different ways to approach them. You can also go back and do some of the challenge activities that you didn't get to do in week 3 or week 4 set of material, whatever week it was. We didn't do all of them. So that's my suggestion for practicing right now. If the exam is a program we have to make, no, you will not submit these on MATLAB Grader. You will not be able to check your results for these. So there will be no MATLAB Grader tab for them. Sorry. Okay, let's go ahead and begin. Because it's loops. It's loops week. I love loops. They're great. Like I said, it's a little harder for students to comprehend loops, but this is our last real universal programming topic to talk about for MATLAB. We will still have plotting, which we will talk over on Monday next week. Next week, Wednesday, is going to be review, and then Friday I will have some extra office hours as well. But we do still have plotting to do with MATLAB, but loops is like the last real programming topic structure that MATLAB has as a general structure that it has. Okay, so let's go ahead and start. So first thing first, write a loop that displays numbers 1 through 20. So we already can do this with just an array. We could just say disp an array that's equal from 1 to 20. So I could just say disp 1, 20, and then let me transpose it so that it shows up nicely. We could just do this. That's completely valid. That's completely valid, but I want to demonstrate how we can do this in a loop, just to show you guys how to write loops, basic loops, and the purpose of loops. So if you go back to the notes, I didn't talk about this in the video because I want to talk about it in lecture, but there are 4 main steps that we can use to specifically write while loops. A for loop is a little bit different, specifically in MATLAB. So let's talk a little bit about writing a while loop. So first things first, determine the purpose of loops for the problem. So this is essentially thinking about what do you want to repeat? Loops, the goal is to repeat code over and over and over again. So what do you want to repeat? For this process, for this loop specifically, I want to repeat printing out a number. Sorry. So I want to repeat printing out a number. Yeah, that's hidden back there. That says number. And so then my goal is to display a number. That's my goal. That's where I'm starting. Your loop, so essentially this is like the body of the loop, the conceptually what you're trying to do. Think about what are you trying to repeat? What are the steps? What are the sections of code that you want to repeat over and over and over again? Because remember, a loop is going to execute the code and then go back up, check its conditional, execute the code, go back up, check its conditional, execute the code, and just keep going in this loop process. That's why it's called a loop, over and over and over again for a specified number of times or until some condition is met. Okay, so think about, determine the purpose. What do you want to repeat? What are you going to keep doing over and over and over again? Okay. Once we know that, then we can go ahead and start to build our loop process itself. So for this one, I'm specifically writing a while loop. So I will put the keyword while. Every while has an end. Whoop. And then make sure things are indented properly. So if you want to indent things properly, you press Control A, Control All, and then Control I for indent. Or you can use these buttons up here, buttons in the editor home tab. You can't see that. Editor home tab, there's an indent right next to comment. Okay, so second one, initialize variables to determine the starting value. So here we're starting to figure out what is my loop control variable. So thinking about my loop variable, and that will keep going for the next 3 steps as well. So initialize some variable to determine the starting values. So here, I'm looking at my variables inside of my loop, and it's called num. So I only have one variable, it's called num. So I need to figure out what is my first value of num. Num probably starts at 1 because I'm printing out numbers 1 through 20. So I'm starting num at 1. So for this one, I want num to equal 1, which means that num is my loop control variable. It's the variable that's going to change inside of my loop and help me determine when I'm going to stop. Okay, so I'm initializing it to 1 because it makes sense from my prompt. It makes sense because I'm displaying numbers 1 through 20. Okay. It's not always going to be 1. It really is going to depend on what your application is, what you're trying to do. So there's not a defined number. You can kind of think about things as concrete, but there's always exceptions to it. So you really just need to think about what am I trying to do? What makes sense? Try something, change it, try something, change it, try something, change it. Sometimes you just have to do trial and error. Okay, but I'm starting num at 1. Then second or third, determine the termination condition. So essentially identify when your loop is going to stop. So this is very important. Identifying when your loop is going to stop. So num equals 1 is my start. The code inside of here is going to keep repeating over and over and over again. So I'm going to keep printing out my value of num over and over and over again. So I need to determine when I want it to stop. So I want it to stop when num reaches 20. Because that's when I want to be done. Based on my prompt, I'm printing out numbers 1 through 20. So I want to stop. I want to stop when num reaches 20. Really when num reaches 21. But I want to stop when num reaches 20. When num is equal to 20. So double equal sign. That's when I want to stop. You're not going to write that in, though, in your while statement. You are going to invert it. So this is very key. This is very important. So first identify when you want it to stop, and then invert it. So what is the opposite of when num is equal to 20? Essentially, or num is greater than 20. This is my invert. Because I want it to continue, I want it to stop as long as num is less than or equal to. Yeah, that's right. In the homework document, I made a mistake on the problem 2 with the shipping. I said weight greater than 1 pound instead of weight less than 1 pound, so that needs to be updated. But once again, I warned you guys. I told you, I'm terrible with my less than or equal than. Less than or equals to, and greater than or equals to. Okay, so this is when I want it to continue, or want it to stop. I want it to stop when num is equal to 20. So that means the opposite of that is when num is greater than or equal to 20. Or greater than 20, not greater than or equal to. When num is greater than 20. It's not num is less than or equal to 20 as well. It's just greater than. And you'll see why. John Cena, ask your question again at the end of lecture. I'm focusing on loops today. Okay, so while num, oh shoot, I said this all wrong. Never mind, I did not say it all wrong. Num equals to 20, so if I invert that, it's num less than 20. Here's my inversion. Num less than 20. That's why I got messed up. So here's when I want to stop. When I get to 20, here is when I want to continue. Sorry about that. Okay. Okay, so num less than 20. It's really got to be less than or equal to 20 because I want to stop at 20. So it's both of them, less than or equal. And we'll see why. And then lastly, write the loop body, which we already did. But one key piece of writing the loop body is modifying our loop control variable. So note num equals 1. Here we go. Num equals 1. Num changes, or num is displayed in here. Now I need to modify num. So num equals num plus 1. So this is a very common modification where you just say num equals num plus 1. If you are practicing C++ or Java, you might say num plus plus. There's no plus plus in MATLAB, so you have to say num equals num plus 1. So here's my modification. Here is my testing of my loop, of my loop control variable, and here's my initialization. So these are the 3 pieces I talked about in the video. Okay, so let's go ahead and see this loop in action. So I would just run it. It just prints out 1 through 20. Let's go ahead and run the debugger just to jump through it one at a time. Okay, so let's pay attention to my variable in my workspace. So num equals 1, and then I reach this while loop. So I'm asking, is the value in num less than or equal to 20? 1 is less than 20, so I'm going to go into my loop. I'm going to display that number, display whatever num stores, and then num equals num plus 1. So now num stores 2. And then I'm going to go back up. MATLAB doesn't go back up to my conditional for some unknown reason, but it goes up to my conditional and asks again, is the value in num less than or equal to the value in 20? So 2 is still less than 20. It's going to display that number, and then now num is 3. So we keep going. We keep stepping through this. Note the value of num changes every single time. So we see all of the num values one at a time. If I keep going, 10, 11, 13, 14, 15, 16, 17, 18. Now num is 19. Whoop, dang it. Num is 19. So then num becomes 20. When we reach 20, we go back up. 20 is equal to 20, so this is still true. So it's going to display 20, and then go to 21. 21, however, is not less than or equal to 20, so then it's false, and then it exits. So as soon as this is false, it's going to exit. So note if we had the wrong initialization. So if num was equal to 100 to start out, num equals 100. 100 is not less than or equal to 20, so I would execute 0 times. If num was negative 10, I start at the negative 10. Negative 10 is less than or equal to 20. I would display negative 10, and I would keep going, and now I would display negative 10 to 20, which is much more than 1 to 20. So our initialization value matters. Our testing value also matters. So if I had less than or just less than 20, if I just had less than 20, I should have chosen a smaller number. We can see when we get to 17, 18, when we get to 19, and iterate to 20, 20 is not less than 20, so we would end there. We'd only print out up to 19 values. Okay, so our testing matters. Our modification matters as well. If I did num equals num plus 2, I would only be printing out 1, 3, 5, 7, 9, 10, 11, whatever, all the odd numbers. If I didn't have this modification, and I just ran my code, notice it never stops. I'm printing out 1 continuously because 1 never changes. If you ever run into this situation, press Control-C. Okay, it'll tell you operation terminated by user during your script file. And that's true for Mac and Windows users. Control-C. So if you're on a Mac, it's also Control. It's not the command or whatever that key is called. And so all of these pieces matter. And Control-C honestly works for anything. Like if you ever want to stop your program early, like if you input the wrong value, just press Control-C. You don't need to go through all the way to the end. Okay, so there's a while loop. A while loop that just displays the numbers 1 through 20. If I want to do the same thing with a for loop's a little bit easier. I have for, and I'm still displaying num. Note the inside is still the same, display num. But now for, I just say that some variable, or num, equals, and then I just list out the values I want num to be. So I want num to be 1 through 20. So these two loops do the same thing. If we do this loop, the second loop, let me comment this out. If we do the second loop, it's the same process. However, for this loop, for a for loop, this variable num is called my loop index variable, and it's going to contain the values in this array 1 at a time. So I kind of harped on the fact that num was a scalar, your loop index variable is a scalar, because this is confusing for students. Even though it says num equals 1 to 20, it's not that num equals that array, it's that num equals the values inside of this array. So if I step, num starts out with a value of 1. I display that number. Then num goes to a value of 2, we can see in my workspace. And then num is a value of 3, and then 4, and then 5, 6, 7, 8, 9, 10. So it's one number at a time. And the question that we're really asking ourselves whether or not to repeat is, have I run out of numbers? So 13, 14, 15, 16, 17, 18, 19. And then when we get to 20, it's going to display that, and then it's going to be done, because it runs out of numbers. Okay, so num is our loop index variable. It's a scalar that grabs one of these numbers at a time. You can do brackets, you don't have to. And MATLAB will tell you that here's some syntax that may work, but you might want to do this instead. In the video, I was a little confused on how the values were being stored. So it's all happening behind the scenes. This is why it's a little confusing for students, because it's not as clear, it's not as sequential. So MATLAB is doing this behind the scenes. It's allocating these one at a time behind the scenes. So num equals 1 to 20. 1 to 20 looks like this. It's just numbers 1 through 20. So behind the scenes, MATLAB is saying assign num each of these values one at a time. So each time you go through the loop, grab the next value. So grab the 1, execute the code inside. Grab the 2, execute the code inside. Grab the 3, execute the code inside. Grab the 4, execute the code inside, and keep going. So all of our variables are still stored in our workspace, so num is still in our workspace. We are just not explicitly saying num equals 1, num equals 2, num equals 3, num equals 4, num equals 5, num equals 6. MATLAB is doing that behind the scenes. It's grabbing one number at a time for us. So when you use a modification, it goes, you can think about it as element by element with a for loop. If that makes sense to you, Joey, yes, I can see how you can think that. It's kind of, it is manually, okay, so that's a really good question. So MATLAB does have element by element operations, which are great, but behind the scenes, an element by element operation is really just a loop that's going through all of the numbers in your arrays to do the calculation. If that makes sense. Okay, let's get on to another example, because I want to go through as many examples as possible. Okay, so here's another one. So it says prompt the user to enter in the desired shipping option, ground, express, overnight. So this is relating to your homework. It's not something you have to do for your homework, but I just wanted to relate it to your homework. Write a loop that forces the user to enter in an appropriate option. So here we have the keyword prompt. Prompt always means use the input function. And then write a loop that forces the user to enter in an appropriate option. Okay, so first things first. Option. Input. Enter in the desired shipping option. Okay. I could display a menu above, and that would be fine. I'm just going to go ahead and stop here. Okay. I'm asking the user, enter in a desired shipping option. The valid options are ground, express, or overnight. So those are words, so I'm going to put my S in there. Okay, so that means the user needs to enter in the word ground, enter word express, or enter in the word overnight. And those are my 3 options. Which means if they don't enter in any of those options, I want to re-ask them to enter it in. So essentially, I want to repeat asking this over and over and over and over and over again until the user enters it in correctly. Okay, so I am going to wrap this in a while loop. And I will explain why I'm going to use while loop in a minute. So when you think about what is the goal of your loop, what is the purpose of your loop, the purpose of this loop is to repeatedly ask the user over and over and over again until they've entered in the correct option, until they've entered in one of these 3 options. It could be on the first time, it could be on the 20th time, it could be on the 17th time. So the fact that I don't know how long that's going to take means I should use a while loop. A for loop should be used when you know exactly which numbers you're dealing with. So for this one, we knew exactly which numbers we wanted to print out. So I could use a for loop. With a while loop, I don't know how many times the user is going to require to enter things inappropriately. So I'm going to use a while loop. You can do anything with a while loop. You can only do certain things with a for loop. Okay, so while I'm asking the user over and over and over again to enter in the desired shipping option. So let's get to step number 2. Step number 2 was figure out your termination condition. So when do you want things to stop? I want to stop when one of these is entered. From a conditional standpoint, that looks like this. If string compare the word ground with my variable, which is OPT. Or string compare express with OPT. Or string compare overnight with OPT. When it's either ground or express or overnight. And once again, practicing those conditionals, practicing when to use or, when to use and, speak through it, talk through it out loud. I want to see if my option is equal to ground, or it's equal to express, or it's equal to overnight. Any one of those should end my loop. Any one of those are valid. Okay, so now I need to invert it. Inverting, if you want something to be true, invert it by putting a not in front. So if it's not equal to ground, not equal to express, not equal to overnight. And then to invert an or, you do an and. So not equal to ground. I can't even read my own handwriting. Not equal to ground, and not equal to express, and not equal to overnight. So it's similar to the if statements we kind of put together last week. Okay, so let me go ahead and type that. String compare, ground, OPT, and not string compare, express, OPT. And there's really an art form to these. The more you do them, the more practiced you will be. Sometimes you just try something, and if it works, it works. If not, you just kind of need to sit there and think through it. But don't be afraid to do some trial and error. Okay? I'm not gonna lie, I pretty much did a bunch of trial and errors until I started teaching, and I was like, oh, there's a better way to do this. So don't be afraid to just try something. If it doesn't work, try something else. Maybe you had or in here. Maybe you have or in here and you would run it and you're like, it's not really working the way I want it to work. So when it comes to loops, it's really important that you test your code, you run your code, you execute your code, you really go through that debugging process and see how your variables are changing. Okay, so I have identified the purpose of my loop. I identified that it's a while loop, and I've identified more or less when I want things to continue, when I want things to stop. So string compare, strcmp, it's string compare. So you can always do help, strcmp. So it compares strings or character vectors. So these are single quote strings. Compares S1 and S2 and returns a logical 1 if they are identical, and returns a logical 0 if they are not identical. So it's checking to see, is ground equal to opt? So is the word ground equal to whatever the user entered it? Okay, so third thing, I need to, oh, whoops, I totally skipped over my first thing. My first thing is identifying what my initialization is going to be. Notice my variable is opt. There's a couple ways I could initialize this opt variable. It's tested in here, so it shows up a couple times. I could just say opt equals nothing. I could just start out with this and just say I want just any initialization that's not equal to one of these to make sure it enters once. I could also ask the user before my loop to get an option. So there's a couple ways that you can initialize opt. You can just ask the user outside of the loop and inside the loop. You could just start out with the word nothing or some valid value that's going to make sure you enter the loop. I'm going to go ahead and start with this one, but there's a couple ways you can do it. But really the key thing is opt needs to be initialized. This needs to be initialized. Okay, so here it's initialized, here it's tested, and now I need to make sure it's modified. So this one's a little bit unclear, or a little bit less clear about how it's modified, but it turns out that in line 13, this is where the modification occurs. So I'm re-asking the user, which means opt should change. Okay, let's test my loop. Okay, so run. Opt equals input the desired shipping option. So here in my command window, I'm going to enter in the keyword ground. So now opt contains the word ground. I get to my while loop. While string compare equal to ground. So this is, or not equal to ground, that's false. It's not equal to express, it's not equal to express, and it's not equal to overnight. So 0 and 1 and 1, this whole thing is false. This whole thing is false. So you can see why with the debugger, you can kind of stop and slow things down. So since this whole thing is false, it exits. It doesn't even enter in the while loop. It doesn't even enter in the loop if the user entered things in correctly. So let's run it again. Let's say the user entered in some garbage. Whoops. Step. Entered in some garbage. So now opt stores this text. So then when I get to my while loop, I'm checking to see, is that text not equal to ground? Yeah, it's not equal to ground. It's not equal to express either, and it's not equal to overnight. So true and true and true gives me true. So now this whole conditional is true. So I step in, I'm going to re-ask the user. So let's say the user enters in something else. Hello. So now opt changes. Opt now stores hello. It's gonna go back up. It's gonna go back up and retest this conditional. Now the conditional is true. It's still true. So it re-executes the code inside, re-asks the user. Let's do overnight. So now opt stores the keyword overnight. Whoops, I entered it in wrong. This conditional is still true. So I keep going. So I re-ask the user, express. So now opt stores the word express. It goes back up to the conditional. Now my conditional is false because they entered things incorrectly, and then I'm done. Okay, so I'm going through this over and over and over again until this is false, which this is going to be false when my user enters things incorrectly. Okay, so that's another example of a while loop. This is called a user validation loop. And as you can see, it's used to force the user to enter things in appropriately. So this is one of those examples where we can make sure that the user entered things in appropriately. So if we're expecting a matrix of a given size, we can check to make sure that the matrix is a given size. If we are expecting a specific word, then we can check to see and make sure that they entered in a specific word. If the number should be an integer, we can check to make sure it's an integer. You guys can look at the project. The project is posted on UB Learns. The description is there. Just go into week by week material. Okay, let's keep going. Let's look at another one. Okay, here we go. Let's hope I have enough time for this. So here I'm going to illustrate more or less a yes, so JR, you could just display a message telling him it's wrong, but you need to still re-ask the user. So we could say display wrong input, but we still need to re-ask the user. So we still need to have this line of code. Otherwise we're going to run into an infinite loop. Because we still need to re-ask the user so they enter in something so that the value of opt changes. So if I run this, so here you can say wrong input, and it will stop when they enter in the right input. If we didn't have this line and we ran it and they entered it in wrong, it would keep running into an infinite loop. Once again, if you have an infinite loop, just press Control C. So JR, that's a really good point. It's important to tell them they entered in something wrong. If this was a more complete example, we would have that. But we still need to make sure that the value of opt is changing. We are asking them again if they want to enter in, or that they should enter in a different word. Okay, let's go through this next example. So this next example is a little bit more of a practical example of an instance where we might use loops practically. So it says the following describes an algorithm to calculate the cube root of a number. Cube root, not cubic roots, the cubed root of a number. So essentially, whoops, come on. So essentially, if we did nth root of a number, 3. Yeah, so we're essentially gonna write a program that does this, that calculates this, where that number is p, for some obscure reason. So it says choose an initial guess, R1 equals p, so R1 equals my p-value. So John Cena, are you not in the class anymore? Or John Cena channel? Obviously you're not John Cena. Interesting. Well, welcome. Okay, so let's step through this algorithm. So here we go. We'll just go through it. R1 equals p. Let's start out with p equals 27. Cube root of 27 should be 3. So here's my first thing. R1 equals p. So R1 equals p. Then it says calculate a new guess as Ri plus 1, which essentially is just saying our next guess using this calculation. So my next guess is going to be, so R2 would be R1 times R1 cubed plus 2 times p divided by 2 times R1 cubed plus p. Okay, that's my next guess. Okay, and then I would keep going. So here it says calculate the error between the two guesses. So here I'm going to calculate an error. So E2, we'll call it E2, the error corresponding to my second guess, is the absolute value of R2 minus R1 divided by R1. So keep in mind, part of your job as programming is to translate this math language into programming language. So when I say R1, that would be my Ri. It's my previous guess. Ri plus 1 is 2. It's my current guess. Okay, so there's the error between those. I'm going to print those out. So f print f, guess equals percent, I don't know, 0.5 f, and then error equals 0.5f. I'll do 10f. Make an error pretty big. Okay, so R2, E2. Okay, so if I wanted to do another guess, I would copy and paste this. And now, oops, R3 would be R2 now, times R2 cubed, plus 2 times p, plus divided by 2 times R2 cubed, plus p, and then my E3 would now be between R3 and R2. Because I'm just updating all of my variables. If I wanted to do another guess, I would just copy and paste that again, and now change R3, or R3 to R4. So now R4 is going to be calculated with R3. So notice how I'm copying and pasting, and I'm changing the same variables over and over again. Okay, so let's go ahead and run this. So P is 27. So my first guess, based on my calculation, is that the cube root is 13.52776, which is not the case. The cube root should be 3. And here's my error. Then on my next guess, R3, is going to be 6.87, blah, blah, blah. Here's my error. So I've essentially reduced my guess by about 50%. Okay, so it's not 3 yet, or it's not where it should be. So I'm going to go ahead and make another guess. Here's my next guess, so I'm getting closer. Still not quite there, so let me go ahead and make another guess. So R5. Notice this is getting a little tedious. This is getting tedious. And I'm still changing things in a predictable manner. So my error is getting closer. Why is my error so close? R5. Oh, because I printed out the wrong values. There we go. So notice my error is getting smaller. My guess is getting closer to 3. So let's do it again. Let's do it 2 more times. 6, 6, 6, and then these ones should be 5. 5, 5. This is what loops are for. Okay. Okay, so there we go. My guess is now 3. My error still isn't quite terribly small between these two, but I'm getting closer. It should be 3. Okay, so it took me 6 guesses, 6 calculations to get down to 27. But get down to 3, which is what my answer should be. Let's say mine was 125 though. Let's say P was 125. My answer for 125 should be 5. Notice in 6 guesses, I get close to 5, but not quite there. So I might need to do a couple more. And I can go and keep doing a couple more over and over and over again. But really, let's say P was 800. So my answer here should be 200. Notice in 6 guesses, I'm not quite at 200. I'm close to 200, but not quite. So, given a specific number, I don't necessarily know how many guesses it's going to take. Okay, so let's start to kind of wrap this up into a loop. So if you notice, copying and pasting, you are doing the same things over and over and over and over and over again. So I copied and pasted this, and then I changed specific variables. I copied and pasted this, and I changed specific variables. I copied and pasted this, and I changed specific variables. I copied and pasted this, and I changed specific variables. The fact that you're doing the same thing over and over and over again means you should use a loop. Okay, so I'm gonna start to do this in a loop. I've done 1, 2, 3, 4, 5 calculations. So I'm just gonna have for loop for I equals 1 to 5. So for I equals 1 to 5 just means I'm gonna do something 5 times. I may use I in there, I may not. For this example, I'm not gonna use I, I'm just illustrating it as an example that's just gonna repeat something 5 times. What am I repeating? I am repeating these calculations. Where R, my next R, so I plus 1, is going to be my Ri from my previous one. Ri. And then my error, so error of, we'll just call error, is going to be Ri plus 1 minus Ri. Okay, so you name your variables whatever you want, unless you're told. But in general, you can name your variables whatever you want. I call it I plus 1 because that's what it's called in my equation over here. It's R of I plus 1. So these are the calculations I'm repeating. Now I just kind of need to fill in all of the other spaces. First, I need to identify what is my initial Ri value. My initial Ri value is going to be whatever P is. Because that's what it told me. Choose an initial guess. R1 equals P. So this is just saying that Ri equals P the first time. So Ri equals P. Let's go ahead and say P equals 27 again. Ri is P. I equals 1 to 5, which just means I'm just doing something 5 times. So I'm going to calculate Ri plus 1 as my previous Ri value in my calculation, and then I'm calculating the error in that. And I'm gonna print out my results. Guess equals, so now it's I plus 1, and then error. I wrote it because I can't say RI. This is an invalid variable name. So I put a P in there for a plus. Okay, so here's my loop. I'm gonna section this off. Okay, let me go ahead and clear my workspace, or not, yeah, I'll clear my workspace. So now let's execute it. So now it executes 5 times, so I equals 1 to 5. That doesn't mean that I is necessarily used. When I say RI, I'm not using this I value. This could be whatever it wants. It could be just count. So it's just saying repeat something 5 times. So in this instance, my loop index variable is not used, and that's fine. And we can see what's printed out. So my guess, and my initial guess is 13.52776. So that's my first guess, the first time I go through this. Here's my error, it's 0.4989, etc. And then I print it out. And then it repeats 5 times. Notice my guess isn't changing, my error isn't changing, because I never change RI. So up here, it was a little more clearer. It was a little clearer. RI or R1 would be P, and then R2 is calculated with R1, R3 is calculated with R2, R4 is calculated with R3, R5 calculated with R4, R6 is calculated with R5. So we didn't have to change our previous number. We didn't have to keep updating RI because we just used our previous calculation. So for this loop, I need one more line of code that just says that RI is now going to be my previous calculation. So I need to say RI equals my RI plus 1. So I'll explain the error in a minute. I know we have like 3 minutes left, but I'll explain the error in a minute. So I just want to illustrate that we need to do this. We need to say that RI equals RI plus 1. We need to say that my new guess, my RI guess, was my previous one. So I calculate it with my initial RI, and then calculate my error, print out my results, and then I just need to say that RI is equal to my new number. So that when I go back and calculate RI plus 1, I'm using my new number. I'm using the previous one. So now when I run it, whoop, now when I run it, we can see my guess changes. Okay, so this is one way I can do it, and I can change however many times I do this. I could do it 20 times. So notice here is what it looks like if I did 20 of these, if I literally typed out 20 of these. Notice if you typed out 20 of these, it would take a very long time to do. However, if I want to just do 20 of these in a loop, all I just need to do is change this number. So, Joey, so I'm only calculating this, or I'm only running this section, which notice it's blocked off by a double percent sign, and it's blocked off. On your editor tab, there's a run section button that you can use to run just a specific section. Which when you run a loop altogether, it's going to just repeat over and over again until it's done. So it just executes the code over and over and over again until it's done. It does it all behind the scenes. Okay, so notice with my results, my initial guess, and I quickly get to 3. So let's say if I have 125, now I quickly get to 5. If I had 8,000, I relatively quickly get to 20. It's all a different number of iterations, but I'm getting there. All of them, though, end with an error of 0. So we can write this loop in a different way as well. So here's what it looks like with for loop. We can rewrite this with a while loop. If I say while, end, and now I'm just going to execute this code over and over and over again until my error gets to essentially 0. So notice here my error is essentially 0. So I can just say while my error is greater than some really small number. So 10e to the negative 10. That's a small number. So I wanted to stop when my error is less than that number, when my error is really small. So I want to invert that and say it's greater than. Once again, just try something. Okay, so this is another way to write this error, or this loop. So let me go ahead. Notice E is my loop control variable now for this one, so I just need to make sure it's initialized. So E equals 1. For this instance, it doesn't matter what your initialization number is as long as it's bigger than this number. So now it prints out until my error is really small. Or in this instance, prints out to practically 0. So for 8,000, it was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 iterations. For 27, it was only 1, 2, 3, 4, 5, 6, 7 iterations. For 125, looks like it's 8 iterations. Let's get some really big number. There we go. Let's see what that means. So once again, not that many iterations, but essentially, or eventually, we get down to an error of 0, and it stops at 54.14581. Let's see, if we did that same loop with the for loop, it would get there. It would get to our number. It would just have some extra iterations that aren't necessary. So both of these work. Both of them are completely valid. My for loop just iterates through 20 times. My while loop just iterates through as many times as it needs to get my error down to approximately 0. Okay. That's it. I went over time again, sorry. Like I said, someone asked a question about the exam. Okay, John Cena. So the exam, it's going to be similar to it was last semester. There's not multiple parts for each question. They should be separate questions. I don't know. Like I said, we're still writing it. It's the same material as it's taught in the last semesters. I don't know. John Cena, do you come it's 9 in the morning. Who just comes on Twitch? That's awesome. That's great. That's great. It's still the same material. It's the same material. I don't know. Maybe I just present it differently. I'm trying to do a lot more examples. So the midterm is going to be, JC, you could just go back and watch the video. But the midterm, like I said, don't focus on the midterm right now. Just know when it is. It's going to be March 27th at 12 p.m. Okay? So make sure you know that date. For right now, the best thing you can do is learn loops. Make sure you master loops. They're harder to conceptualize. It's harder to think about what's happening because you can't see all of the code rolled out essentially. It's going to repeat. It repeats this code over and over again. So it keeps jumping back to a specific location. So it's harder conceptually. So the best thing you can do for your exam right now is to learn loops, master loops, do your homework. Okay? With that, I'm going to jump over to office hours. Also, note, I know I'm preaching to the choir since you guys show up to class. Make sure you start your homework, homework 6 and homework 7. Make sure you start them a little bit earlier. I noticed last Wednesday, Discord was kind of blowing up at the end of the day. So Discord's blowing up at the end of the day, and office hours were very full. So make sure you guys start it earlier than Wednesday afternoon. Hopefully, if you have time. So for the project, just follow. Your goal for the project right now is to glance through it, get a feel for what is the scope of the material. What do you have to write? What are you going to have to submit? You do not need to know all the details. You don't have all the information yet. You will have all of the content next week. So for the project, your goal is to determine whether or not you want a partner. So make sure you find a partner. If you do not know anybody, use the Discord, use your resources. I am not going to assign partners if you cannot find one because I've given you resources to contact other students. So make sure you guys find a partner. Make sure you submit that declaration form before the midterm. So you've got 2 weeks to find a partner. But that's your goal right now for the project. You do not need to start it necessarily. After the midterm, that's when I suggest you start the project, because you'll have all the information and you're not going to be worrying about the midterm anymore. Okay. Any final questions? I feel so bad because I'm not in office hours, but any final questions before we head out? Lots of good discussion today. Lots of good questions. John Cena, I like your input. That's great. I'm glad you and Matt had some nice chatting. Yes, so for the project, you can go solo. That is completely legitimate. You do not have to work with a partner. If you want to, you can, but you do not have to. Anything else? Okay, with that, I will jump over to office hours. I'll probably see some of you guys there. Some of you guys are probably already there. And I will see you guys on Wednesday for more examples. And also on Wednesday, I will go over some tips on how to do homework 7, just because it is different. Okay? So with that, I'll see y'all later.